Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of basic mechanical engineering. We'll dive into key concepts like elementary theoretical aspects of production processes like casting, carpentry, welding etc. Slide 1. Introduction to production processes. Let us begin with understanding what production processes mean. A production process refers to the method through which raw materials are transformed into finished goods. This transformation can happen through processes like casting, carpentry, welding, machining, and forging. Casting is when we melt a metal, pour it into a hollow mold, and let it solidify into the desired shape. Carpentry deals with shaping and joining wood using tools to make things like furniture. Welding helps us join two metal parts using heat, and sometimes pressure. Machining is where we remove material using machines to get the final shape, like drilling or turning. Forging involves applying pressure or hammering a hot metal to shape it. Each of these processes is important in the real world. For example, casting is used in engine blocks, carpentry in making furniture, and welding in structural frames or pipelines. We select the process depending on the material, shape needed, and mechanical strength required. Slide 2. Casting, definition and features. Now let's discuss casting in more detail. Casting is an ancient and widely used technique. It begins by preparing a mold, which is a hollow space shaped like the object we want to make. Into this, we pour molten metal. The pattern is the model of the object we want to create and is used to make the mold cavity. To create hollow sections inside the casting, like in pipes, we use cores. A riser is an extra cavity in the mold that stores excess molten metal and feeds it into the casting as it cools and shrinks. This helps avoid empty gaps. When the metal cools, it undergoes shrinkage, meaning it slightly reduces in size. So the pattern is made a little bigger to compensate. After solidification, the casting is cleaned and finished, a process known as fettling. Example: iron pipes, gear housings, and machine beds are made by casting. Casting is especially beneficial when you want complex shapes, larger sizes, and lower production costs. Slide 3. Carpentry, definition and tools. Carpentry is a fundamental skill used in working with wood. The carpenter uses tools to measure, mark, cut, join, and finish wood into usable products. For measuring, tools like steel rules and measuring tapes are used. To ensure right angles, we use a tri-square. Cutting tools include saws, chisels, and planes. Marking tools like marking gauges or pencils help define where to cut or join. Wood can be joined in many ways: nails, screws, glue, or by specially cut shapes. One common joint is the mortise and tenon, where a rectangular hole, mortise, and a matching tongue, tenon, fit together. After joining, finishing is done by sanding and polishing. Examples include furniture, door frames, and window panels. Carpentry is simple and cost-effective but requires accuracy and craftsmanship. Slide 4. Welding, definition and types. Welding is a very common technique to permanently join two metal parts. Let's understand the key types. Arc welding creates an electric arc between the metal and an electrode to generate heat. Gas welding uses a gas flame, commonly from a mixture of oxygen and acetylene. MIG welding, metal inert gas, uses a wire electrode and shielding gas. TIG welding, tungsten inert gas, uses a non-consumable tungsten electrode and gas. Different welding types are chosen depending on material, thickness, and required strength. During welding, defects can occur, like porosity, tiny air holes, cracks, or undercuts that reduce strength. Example: welding is used in automobile repair, pipelines, and making storage tanks. We also use electrodes, which conduct electricity during the welding process, Some melt to fill the joint, consumable, others don't, non-consumable. Slide 5. Advantages and disadvantages of each process. Now let's compare the three important production processes, casting, carpentry, and welding, based on their practical advantages and limitations. Understanding both sides helps us choose the right process for a specific job. 1. Casting. Advantages. Casting is ideal when we need to produce complex shapes and large components. It's also cost-effective, especially for high-volume production. Disadvantages. The surface finish is usually rough, and the product may suffer from defects like shrinkage, porosity, or cracks during cooling. It may need extra finishing steps. 2. Carpentry. Advantages. Carpentry uses renewable wood, which is eco-friendly. It needs simple tools, and most parts can be reused or reworked. It's also relatively easy to learn. Disadvantages. Wood has low strength compared to metals and is vulnerable to moisture, which can lead to warping or decay. Joints may not be as strong or durable as welded or cast parts. 3. Welding. Advantages. Welding creates strong, permanent joints. It is versatile, can be used on various metals, and is often more economical than bolting or riveting. Disadvantages. Welding requires skilled labor and poses safety risks due to high temperatures, sparks, and UV exposure. Defects can form if not done properly, like cracks or weak joints. Summary comparison. Use casting when you need complex or bulky shapes with lower cost. Use carpentry when working with wood-based structures, especially where environmental friendliness and ease of assembly matter. Use welding when you require metal joints with high strength and permanent connections. Always select the process based on material, strength requirements, shape complexity, budget, and safety considerations. Let me know if you'd like a visual version, comparison table, or any additional examples added to the slide.